you all. South Florida, mi gente. We have a treat in store for us tonight. We have one of our very own CNCF ambassadors right here in South Florida, Angel Ramirez, presenting on Kubernetes Bare-Metal Clusters for optimal performance. And so with that, I'm going to hand it over to Angel, and looking forward to it, Angel. All yours.
Thank you, Case. Thank you so much. Yeah, actually, you said something very true. Is that there's a lot of conversations today about you know cloud, non-cloud, public cloud, bare metals. Like, what is all these posts about? Why are we even thinking again on coming back to bare metals and on-premise? And I'll gonna do my best to try to put all these together into a presentation. And I also have a quick demo, brief demo. Um, but the concepts are the ones that I really want you to take away from this talk. And feel free to ask questions at any time. Interrupt me. I'm happy to answer the questions. I think that's the biggest value here. So one of the things that I'm going to do first, I have a very brief presentation that I want to go through, and then we're going to jump right into them. So let me just present my page right here. All right, so and here is, just let me know as soon as you can see my presentation, please.
Yep, can see it.
Awesome, awesome, perfect. So um, as Kay says, the title is we're looking at bare metals when we are looking for optimal performance. And first, I want to just take this out of the question. This is not a fight between prem and public cloud, right? But we also need to understand what are the pros and cons of each one, and when we want to choose one versus the other, right? So, but at the end, we want to focus on optimal performance always, right? So, just a little about me. I'm a CS ambassador. I love community. That's one of the things that I really passionate about. That's why I like to share the knowledge here in the community. I'm also the CEO of Cuemby, which is a company that focuses on helping organizations doing the what we call the cloud transformation that we're still doing for the last 12 years. And it's kind of like interesting that even though that it's been a long journey that the technology is doing, we still haven't figured out a lot of stuff, right? And that's interesting. And especially, and now going into the topic is like is Kubernetes, right? So all this revolution happens because now we have these awesome orchestrator, but at the same time it's awesome and bring complexity to what we do in our daily life. And we want to figure out what's the best approach of using Kubernetes. And the reason why I'm bringing this up is because when Kubernetes, the way that we use Kubernetes today, I'll say 80% of the time, is all right. So we're using managed services from different cloud providers, and then we have this one-click deployment where we just have a cluster, right? So there's a lot of magic behind the scene happening that, for most cases, that is okay. The point is when we have these scenarios where, hey, I really need to have a really high performance, and let's bring some ideas like, what if I'm a fintech, right? And latency is things that it really concern me. What if I'm a telco and I do really need to have a really high performance network? What if I'm a trading software? So, and I'm not limited only to these ones. There also could be cases where, hey, my reasons is I do really need to have my environment in a very secure, or it has to be a very specific way set up. Or maybe I'm a government and I can just not be in a public cloud. So that's when all these questions about on-premise and VMware start to come in, right? And one of the things that I really want to kind of like clarify before we get into the bare metal is that what really means bare metal and what means virtual machines and virtualized environment. So as you can see here in the screen, so there are two scenarios, right? So the virtualized environment usually is a system, a layer, a operating system that is based, which is common in both. Then you have your compute, that's right there. But then you have layers, right? In case of the bare metal, that's it. That's all you have. Your operating system, and you run your application right there. And then in the you have multiple environments, or let's call it virtual machines running. That on top of that, then you run your application. So just to backtrack a little bit and in the history, um, I don't know if I've been long enough in the industry to kind of like have experience working on data centers and also on public cloud. But what happened is back in the days, we have these servers and we have to manage all of it, network, storage, everything. It has to be done by us. And then that's where all the sysadmin the skill sets and knowledge had to be in order to even use them, right? And I remember that you used at that time you had that machine and you deploy a virtual machine somehow somewhere using Proximus, whatever all the software you guys like, and that's how we used to manage applications. Then the IIS word came in where it says, you know what? Why are you even bothering managing your own servers? Let me give you a hand and use mine. I'm going to put a layer on top of it where you don't need to worry about the networking or storage. All you have to do is open a console, you click virtual machine, and voila, you have your virtual machine. Everything else is ended by me. So that was the IIS, or most common as infrastructure as a service, what we know today as AWS, Google Cloud, and I actually even remember using one-on-one. For those that maybe are old enough to know what I'm talking about, the one-on-one where you had your private virtual servers and then you pay for them and they turn on and you have them. So those are infrastructure as a service. So you get infrastructure, but you don't manage everything. You just get the compute part. And then we end up moving in the timeline to like platform as a service, where the layer goes even higher. So you don't even have to manage the virtual machine. You just deploy runtimes, which is what we know as Heroku or other type of system. But the thing is that why am I explaining all this and why it's relevant? It's because then came up Kubernetes and said, cool, now we have containers, right? Containers, Kubernetes. So containers is something that runs very small. It runs on top of an operating system, and you can spawn so many of them, and the speed is a lot faster, right? So spinning a container is a matter of seconds versus a virtual machine that even if your system is way fast, the faster that you can have, still it's going to take few minutes, right? Let's be fair. It could take anywhere between 5-10 minutes per set. So at that point, so what we did as an industry is like great, let's put Kubernetes on top of the virtual machines, right? So that's what we call today, let's say AWS Fargate or Google Kubernetes engine. So at the end, they're running on top of virtual machines that are on top of the bare metal. So as you can see right there, that is a lot of layers that you're dealing with. You're dealing with the with networking overlay. You're dealing with multiple layers of the storage. So you, at the end, you're adding latency in a way, in multiple ways to your application that at the end is running in a container. So this is where we now say, hi, what if we have to what if we remove the virtualization layer? And I know some of you might say, Angel, come on, like that's the whole point of virtualization is that you have multiple spawning in multiple places and you can have that benefit of like of removing a virtual machine, putting it back again, and doing some sort of like a backup in an easier way. All that is true, but the thing is that now we have Kubernetes. So um, if Kubernetes is already as our orchestrator, already manage containers in a very efficient way, and also have all these tools around that you can do backups, we can deploy storage. So what really what is the benefit of virtualization at that point? So just bear with me. I know that some of you might be like, come on, and you're talking about the virtual machines and all that. So that's very secure, it's proven methods, all that. So just bear with me, and you will see that at some point you might see a use on the value of working directly with bare metals. There's still couple of things that we need to cover before we get into the nitty gritty and the demo, right? So we need to find the real synergy and what's going on between Kubernetes and bare metal. And at the end, there's two main points. One is is the performance, right? When you're running a container on top of virtual machine versus a container on top of the actual CPU or operating system, there is a huge difference, right? Because at the end, you're doing a layer, the container running the virtual machine is running on that, it's called a kernel virtual machine, that then is translated into the operating system virtual machine kernel. So that basically right there is some latency that is going on, right? Versus a container running directly on the bare metal, you're getting all the benefits, right? So that's one of the performance gains that you're having right there. And the other one is that what I was saying is that you might end up yourself looking at applications that requires certain level of latency or criticality that when you're running on the bare metal you will have. Also, there's an interesting scenario that we will discuss at the end, but it's related to, of course, the hot topic of today of the today's day, AI, right? So I'm going to touch upon that later, but I just wanted to keep it in mind that um, although this might sound like if we're going backwards, we actually in a way moving forward. And I'll explain that. So now some pros of using Kubernetes on bare metal. I've been talking about that since the beginning, but just to point that out is like the performance, right, and control. So this one for me is actually, besides the performance, the most important one. Um, for me, I like to have control what's going on. I kind of don't like too much the magic. I want to know exactly what's going on, and that's why I invested my time on learning about cloud computing, how the infrastructure as a service works, what actually all these public clouds are doing, how is it underneath the system that is going on, because I really want to understand what's going on in control and see if I can make it better and see if I can make it more performant. So that's kind of the type of person that I am. So, but at the same time, it's kind of like a pro that you have it because you know exactly what's going on, and especially in environments that you might be able to reduce noise, right? For example, I don't know what type of operating system is using X, Y, and Z offering. But if I'm doing it myself, I know exactly what I'm doing, and I know exactly how I want to maybe from the security standpoint harden it, right? So there's so many opportunities that I'm getting out of these choice, right? We already talked about the cases, and in this case, AI. So we all know that AI is heavily dependent on GPU, for example. So handling GPU, I don't know if you any of you have that experience or have done it before, even if as a test, but handling GPUs from the virtualization standpoint is kind of challenging because you basically passing the GPU, um, uh, um, you know, basically passing the GPU to a virtual machine. So the virtual machine basically simulates that, and then you access it through that. So it's kind of like when you open the virtual box and you're creating a machine, you're creating a virtual CPU. So it's emulating your CPU in the virtual machine. Same thing will happen in the GPU. So of course, there are techniques that you can make it way you can make basically to pass that, and but still it's way too complex. It's easier to just access the GPU from the terminal machine, right? And then just install the drivers, use it right there directly. So that would be one of the use case that I would put on top of the one that we already discussed, right? And of course, there comes, right? Nothing comes out of without cost. There's always a cost involved, and the cost is expertise. I would say that that's the biggest one because you might not be able to do it without having previous experience on networking support, how to manage for example, there's going to be a lot of like BGP involved that maybe in a public cloud you might not really have to use because everything is handled by you in multiple ways. But those IPs that need to be propagated in a way in the working side. So yes, that is potentially the most impactful con of using bare metals. But at the same time, it's kind of like you just have to like balance that out, right? Either you have control or you don't have control in this type of environment. So that I would say this the one that we need to definitely consider as a huge impact from using bare metal. So I'm gonna make a quick pause here just in case I'm gonna check if there's any questions or comments before we continue. Okay, cool. So I think the next one is kind of like the I'm gonna leave this slide for after the demo because the thing is I'm gonna be showing these best practices and tips while doing the demo. So just kind of like a entry of that is that definitely if you're gonna get into the bare as a service or bare per se, you need to use public tools because you cannot. It will be hard to get away by doing everything manually, right? Especially when you have to when you dealing directly with the bare and the operating system, and then on top of that, you have to manage things that goes on top of it, like packages and all that, and keep it updated. So you don't want to do that manually, for sure, or at least the least manual possible. So that I will be showing you guys how that works, right? And of course, it's always good to have a disaster recovery plan because you're dealing with the bare metal. So if in the virtual environment you might get away with a machine going down and spinning the backup really quick because of maybe using some type of software that allows you to do that. In this case, you may not have that luxury that simple. So you want to make sure that there's a disaster recovery plan attached to it. And what happens if a node? Because in this case, when you're dealing with bare metals, you're dealing with an actual node, and if you put that into it, let's say data center context, so you're basically dealing like let's say they have a rack, and that rack have multiple servers, and one of them fails, like I said. So that's why most of these data centers come with redundancy, low power, all that. It would be like hard to find a data center that does not have all that already, but you have to be aware that you have to find a way to mitigate that for sure, right? Let's see here. There's a comment. Oh, yeah, thanks. Yeah, the environment control. Yeah, definitely. It's one of the things that I really enjoy is to have full control of what I'm doing. It's the only way that I can guarantee myself that I'm doing something that that I can guarantee, right? Um, so gonna go straight to the demo, the fun part. So what I'm gonna showcase is, of course, I don't have a data center, so I cannot do this in a real data center. But luckily for us, there's a lot of new offerings that you can use and it's still bare metal. For example, there's ton of them. I'm gonna be using today Equinix Metal. So what it does is just now I can instead of requesting virtual machines, I can request bare metal servers, literally, and get them and use them. There's more of them. I think there's Kelway also for bare metal machines. I believe also there's another one. I forgot. Best or something like that. So this some of them. Hesner, sorry, that's the name. Hesner also offered them the service. So whichever you want, take it, pick and use them. I definitely suggest that at least you try, even if you're not a big fan of using bare metals or you feel more comfortable with public cloud. But it's a really fun experiment that we're going to be doing today. So let's jump into the demo and then we come back to the slides in a second. So I'm gonna switch to my studio code, and I noticed that I'm not sharing the studio code. So let me stop this. And, I'm going to share it again. Give me a second. On the Here you go. So share my screen. I'm gonna share the entire screen here. Please give me a thumbs up confirmation. Size of the font is good, bad. Is it good enough?
Yep, looks good.
Awesome. Thank you so much. So, all right, let's take a look at some open tofu. uh, Open tofu, Terraform. Uh, at this point, this is the same. Anyways. So right, so let's take a look at what I have here. So I'm gonna walk you through a project that I built, and I'm gonna be posting this in my repository. So as soon as we finish it, I'm gonna deploy it and send it to Hitomi so she can help us out putting on the documentation of the South Florida. But what I have here is this is basically an infrastructure as code that I built. That what it does is it does multiple things. One is it set up a Kubernetes project, which I'm gonna give you a walk through the dashboard in a second. But just to give you an idea, I'm gonna build a project from scratch. Uh, but I lied there. I already built the project because that takes at least 15 minutes. So I don't wanna waste 15 minutes building that. But you bear with me and follow me on this one. So it builds a project. It brings a bunch of machines that I'm going to show you in a second. And on top of that, I create automatically SSH keys. I, I create a BGP sessions because not in this session, but I'm planning to do a second part of this where I'm going to show you how BGP works on this and these scenarios and how we can start getting into nitty gritty of networking. I also do yes, BGP sessions, SSH keys. I get public IPs using global IPs, which I'm going to show you also as well, and how that works because we're going to be tied to BGP. And last but not least, we're going to install Kubernetes. That's the whole demo, right? Now, interesting enough, and you're going to see, I'm not going to use only Terraform. I'm going to use Terraform, and I'm going to use also Ansible. And the reason why is because I found, at least in my experience, and I'm happy to take pull requests if any of you have a better way to do it. Um, in my experience, provisioning services, resources, Terraform, Pulumi, all these tools does a great job. Configuring them though is I found myself a little like in the fence because I still feel that Ansible does a better job configuring resources. Like for example, in this case, servers like installing something on the server, making sure that the package is updated. So I found that Ansible still does a better job, or maybe in my opinion, does a better job for this. So I'm gonna walk you through the whole project, but before I wanna show you what I have so far, right? So I'm gonna open this website right here, and I'm gonna show you the Equinix Metal. So this is Equinix Metal, right? So just to give you a quick tour. So I have a project. It's called Equinix RKE2. I'm gonna use RKE, but you can use whatever you want. It's not tied to one specific binary or distribution. And as you can see here, we got 6 servers, right? Actually 5, because the sixth one we're gonna do it together and live. So in this case, I have 3 servers that are gonna be my control plane. They all deploy in the Silicon Valley um, zone, and then I have 2 data planes. So let's call it workers. So what I have here is that they're all running Ubuntu 2004, right? That's the distribution that I chose to do, and that's it. That's all we have. They're all empty right now. They have nothing, right? So nothing is running there. It's really empty. And when I show you how to add a new server, you will see the whole process how it looks like. Right now, let's jump back in. Oh, by the way, sorry. Let me show you the networking. So as you can see here, I also created 2 public IPs. This is a really nice feature that I love is that you can have IPs, public IPs for per region, but you can also request IPs global, and means that you can attach that IP to any server anywhere in the entire ecosystem, right? And that's they do it through a really nice feature that they have, and they also have a feature that I use a lot in my deployments, which is packet transfer, which allow you to use these private IPs that every server gets when it's deployed, and you can communicate between regions without having to create VPCs, nothing. They just see each other via networking. So it's pretty cool, that feature, right? But we're not going to use that one today. Well, that will be in the second part. That's related to BGP, but just keep that one in mind. So, all right. So now that we have a server, right? The five servers. I'm going to walk you through the installation of Kubernetes. So, like I said, I have all these here, and I have actually an interesting feature that I built in this Terraform code, which is second. Let me open it right here. So on the outputs, I built this. So because Terraform, right, and I'm just opening this one real quick. The inventory. There you go. So I don't know if you're familiar with Ansible, but usually you have to have these posts file where you need to know, okay, these are my servers. This is what I'm working with, right? So instead of for me building this from scratch and manually, I thought can I just build it once I provision my servers, and I found that yes, we can do that. So how I did it is I created this output, how you see it here, and this output basically, let me just remove the empty screen. I'm gonna run it again. So what I'm doing is I'm just once I deploy all the servers, I'm iterating to each one, and I creating that format into an inline, multi-line output, and then I'm using another Terraform right here, another Terraform resource called local file, and then I'm just getting that content and putting it into a file. So I don't have to remember, oh, I created a new server, I need to update it. No, I'm just running my Terraform. Terraform will update the INI file as my host, and then the next time I run Ansible, it will know about this new maybe server or this new configuration that I have. Like, and the same thing I'm doing with the group bars. And group bars is a file that is used to maybe do some configuration that you want to do and kind of inject into the playbook. So, for example, here I have a lot of information that is being already pre-populated, but for example, this token that you see here is coming out of Terraform. So I'm not putting it manually, it's coming out of Terraform in this output that you see here. See, I'm creating another output. I'm putting some data manually just to make it faster. But for example, I'm getting the token automatically, right? And the same thing for the RTE version. I'm getting it from my variables. Right. So enough of this one. So how this works is we're gonna do two steps. First, I made an adjustment on the Terraform file. So let's run it first, so we can see how it looks like. So I'm gonna do one of my commands that have, and I do have a lot of aliases. So please forgive me if they might not make sense to you. But tofu basically means tofu init, tofu plan, tofu apply. Um, it's crazy, but it made me do all those two commands at one time, because usually you have to do tofu first init, so it recognizes if you have a new module or not. Then you have to do tofu plan to make sure that everything looks good. And last but not least, you will do the apply. In this case, I do have a new thing, a new change, so that's great. And then I will have to do apply. So, but instead of doing all that, I'll just do software, and it will just run all these commands at once. So, yes, I accepted this new change. But basically, it's very simple. It's just removing that empty space there that it really doesn't help. And that's it. So, run it, and voila. Good. So now, next step, let's install Kubernetes, right? So to install Kubernetes, I'm going to be using the Ansible playbook. So just to give you a quick walk through the Ansible playbook that I have here in this all-in-one. So it is right here. All right, so I have this site. This site calls three commands: the pre-configuration, the install, and the post-install. The pre-configuration, I'm just doing basic settings that, by the way, none of these so far is specific to the metal. So this is something that we would do regardless if you install RKE2 into a virtual machine, into anything. So they just simple steps. I'm just making sure that some patches are installed. I'm just making sure that the UFW is allowing some ports because I mean the Ubuntu have this firewall built in. So I'm just disabling that, disabling swap, like on any other installation of Kubernetes, and just putting some configuration files that are needed. These configuration files, just to give you an idea, are basic. They all exactly the same if I'm installing in virtual machine so far. So just making sure that the kernel doesn't panic, some container runtime configuration. This is very important, especially because we're doing containers. And you need to make sure that they bridge between them, and then you have the container D, which you need to do the overlay and BRT and the filter. So all none of this is new so far. The only thing really new here for terminals in this case, it will be on the install of the RKE2. I'm bringing some specific files that I want to use. For example, besides from sim manager and all that, so I'm just making sure that the ingress, right, Nginx that I'm going to be installing does not use the controller, the cloud controller, because if I go back to the presentation real quick, and you notice here that Kubernetes have one component called the controller, the cloud controller. That's the one in charge of making sure that when you ask for a load balancer type of service, he will say, huh, you want a load balancer? Great. So it happens to be that I know that I'm running on AWS. So AWS uses the application load balancer. So let me go and request one application load balancer. Let me configure the application load balancer to tie to my workers' IPs, right? So from now on, when you're requesting, you're getting into that load balancer IP, the English class knows what to do and route it to the right service. That's how it works. That's what the cloud um, controller basically does. Also, is the one that when you ask for the, let's say, well, that's the CSI in combination as well. But anyways, when you ask for the volume, I want to use the volume of EBS or anything like that. So it's involved in that, right? So it's kind of how it works. In this case, we don't have a cloud controller. There's no cloud. It's a machine, right? So basically, he doesn't know what to do when you ask him for a load balancer, right? So when you don't know what you're asking for a load balancer, you have multiple options. First, you install the Nginx controller and basically use the normal node port that offered to you. You can use something like Metal FD that simulates that you're getting some IPs from there. Um, you can also use just the IP from the server to basically get some requests, and that works as well. So basically, you have all those options. In this one, RKE2 have this particularity that you can configure in this way, where now basically your English controller will does not require a load balancer, but it will use the IP from the actual server. It's not the recommended way that I would say, but once again, before we get into networking second part, I want to show you how actually you can configure this. All right, so that's probably the only thing that I would say that is kind of only or maybe you may need to be aware for bare metal. Is the load balancer thing, how you know how you handle the services as a load balancer, right? Okay, so that being said, we just installing Longhorn to handle all the storage, and I'm using Cilium with Multus just because I love Cilium and actually it plays very well with Multus. So that's the only reason, but it doesn't really have to be. Okay. That being said, let's go ahead and do it. I'm gonna run it, Ansible, and playbook, and run this. So basically, I'm passing the host file, and I'm gonna be passing also what playbook I'm gonna run. So let's do it. And you do work. What's up? Am I in the right place? Well, that would be helpful if I'm in the right place. Invincible. Right, so I'm in the right place now. All right. So this is gonna take a minute, right? So while this is running, right, I'm gonna explain a couple of things that we need to consider when we're dealing with this, right? So um, first thing first, let me show you the Nginx console. And like, for example, in this case, we're using servers that are using the following networking. You go to one of the control planes and get to network. Right. So we're using servers that are layer 3 bonded. So what this means in this specific case is that the servers are in layer 3 mode, right? And the bundle. So meaning that the in this case the servers have two network interfaces that are basically linked into one called bound zero. Please let me know if I'm getting way too deep on networking, and if you want me to like do one step back and kind of like break it down into pieces. But this is important because you have multiple ways that so you have multiple scenarios that you will find yourself when you are in bare metals. So yeah, bare metals. In this case, because I'm using bare metals as a service, the networking side is kind of getting by default like me like that, right? Bounced into one interface, and what that gives me as a value proposition is that I have redundancy right there on the networking side, meaning that if by any chance one of the mix fails, the other one is replying, right? Now, if you ask me, Angel, how would you do it professionally? I usually have two ways. So I wouldn't use layer 3 bond mode. I would use hybrid, right? Bundle. Why? Because in that case, I have not only layer 3 and layer 2 into the same as a hybrid, so it's also going to be bundled. So I have double redundancy in that case, right? And also because um, that will be kind of like okay, so now I have two layers compressed into one, so I have that luxury. Now, this other way that we can also do it, which is not having any type of layer 3 and just having all in layer 2, right? Bonded as well. In that way, but the real difference and make it to make it a little simpler here is that in layer 3 we got this public IP. If you go layer 2, it's not public IP, it's all private IP, right? But at that point, you have to end up using, you know, VLANs and that kind of stuff. But that's why I don't want to do it in the part one because I want to keep it level. I want to keep it simple so you first see the benefits of running this on the metal and how easy it is before we get into the nitty gritty how you would do it professionally, I would say, right? But this is at the type of cases that you might find yourself in bare metal. Like in this case, great, I have a layer T3 available for me with a public IP, so awesome. But if you're not using something like Equinix, for example, using your own data center or something like that, you may not get the layer 3 right there. You will be probably in layer 2. Still works in the same way. You The only difference is you might have to have some sort of a load balancer up front that you can use then to access from outside to the cluster, or if you don't mind or you don't want to access from outside, even better. You should have the cluster inside of the layer two, and it's that kind of like the private layer. Also, another thing that impacts here, because some of you that may already using Bare-Metals might think, hey, but how you get internet and that kind of stuff. So in this case, when I get layer three, because I have a public IP, I have a way next to the internet, versus some other environments of Vimeo where my exit will be handled by firewall or something like that. Right. So just keep those two in mind, because there are two type of a way to see these type of cases in Vimeo. Right. Let's go back to the code and see if everything works. Well, it's working. So far, it just installing all these packages. And by the way, I did something. Oh, I forgot to mention something. Sorry about that. Something that I did here on purpose is that I deployed an old version of Kubernetes. There you go. I installed the 126. The reason why I did that is because I want to also show you how you can upgrade the cluster using the same system with no downtime, right? Because that's the whole point. You can just do it and deploy it, and you won't feel downtime. Of course, the API server API, you might not be able to get for a second, right? Um, from the outside, but you will be able to basically upgrade your cluster, and none of your deployments will be affected. And especially because of this, right? I added multiple sense to that communication. So if server one of the API is down, server two is also available. So it's not just type 2.1. And we can also solve this issue by doing another redundancy using BGP, which once again that will be session two of these the Meros performance. Let's see how the script goes. It's almost done, so it won't take long. At this point, what it's doing is just making sure that it's draining anything that is on the system, and it will deploy. Right? So we just give it a noise. Yeah, it's almost done. Version change. Okay. Not doing that. There's no changes to the version. Final steps, and we almost done. There you go. So now, how we know that Kubernetes is installed? Well, in the script, I told them to put on the temporary folder the configuration, the kubectl that we need to connect. So let's try that. First, let's see if actually we have that file. Actually, I'm going to do it with cat. I'm going to do the TMP, and right there, we got the file. So in TMP, we have the file. So, all right, so let's do the following. I'm going to do an export kubectl equals to temp, and reconcile. By the way, if you have questions in Spanish, feel free as well. Don't feel that have to be only in English. We can do it in Spanish as well. Okay. All right. So now let's take a look at kubectl, and let's get the numbers. Right, so we have a cluster. It's RKE2. It's running, the version 1.26. Let's see what else we have. We got the service, perfect. We got the cluster IP. Also, let's get all in space. All right. Okay. So these are all the services that we have. By any chance, do we have? Let me see if I can see here. Ingress connection. There you go. Ingress Nginx. Looks like the Nginx is not there. So we're going to take a look at that one in a second. Let me see if I actually copy the, yeah, I copied the file. And we have it, yeah. So it is there. Probably is doing the bounds. All right, so now how this looks like, and I'm going to walk you through one of the servers first. Let me take the IP of one of them. Let's see this one. This one. Okay, so let's SSH into this server. Connects key root. There you go. Right. So we're inside now one of the servers, and let's just explore what just happened. Right. So because it's our key to, we have two places that we can take a look at. We have the, of course, the SCD rancher, and then we have the R key to. There we go, and we have three files there. We have the config, we have the PSS, which is the pod standard policy. Uh, there you go, and right there, that's the animation configuration for the possibility, and we also have the config. And here's the config. So if you see, basically, this file was created out of the same configuration that I used there, right? So we have the TLS sans, which basically means you can connect to the server pointing to any of those IPs without issue. It will work. And we also have the stains, meaning that do not deploy any pod that is not meant to be on the control planes. And simple other configurations. I enable, for example, Cilium with IPv4, IPv6, all that. So I just put this extra goodie so you can see that everything works just fine, right? And this is the important key. We disable the cloud controller. Disabling the cloud controller is that's why now everything is working at the basically bare Kubernetes level. There's, if you're asking for a service load balancer, it won't give you anything. It will be like it's handled by the Kubernetes. And for these, we usually have something like the you can use here multiple tools. You can use the Equinix controller manager, which all it does is when you get a new service of type load balancer, it will connect to Equinix. But because we want to avoid a cloud environment, right? That's the reason why I removed it, because I want to mimic in a way a true data center environment where even though that Equinix have that feature, I want not I don't want to use it. I want to just deal with the bare metal. Like um, so that's one case, and just pretty much the default configuration that we need, the token and the connection, right? So you can see the primary server is the one that ends in 39, which is here, but I also have the 233 and 219. So what we can do, just to see if this works, right? I'm gonna open a new tab here. I'm in the right place. Yes, example, all in one. Perfect. And let's get into the answer. Oh, this is so I'm gonna go now and I'm gonna copy the temp. Right? Okay, what? Let's just go straight to temp. Right? And now where we are in temp, I'm gonna make a copy of the Equinix file, and let's call the Equinix file, and let's call it to right. So why I'm doing this is because I want to see if I can use a different IP to connect to a server, and that will confirm that we actually have a high available plane, right? We do that. That's 39, and we said that we have how many IPs? We have this one, 233 now, and now we can just remove this IP and put it in here, right? And now let's do another test. kubectl config Equinix 2, right? And let's do the it worked. So I actually I can connect to the cluster in high available mode with both IP. And if I change it to the third IP, it will still work. So to this point, we have a high available control plane in a data, let's call it bare-metal environment, right? And now what we have to do is deploy something, right? Is deploy whatever and see how it works. So for that, I'm gonna do kubeconfig equals to equinix 2, and that's good. And then let's do kubectl and actually can UK is not. Things that if I UK is not, I won't be able to show you exactly what. Yeah, you'll be there. You'll be there. So now let's deploy something. So I'm gonna exit. I'm gonna kubectl. Okay, there's I actually have the famous deployment here called uh, just copy the link so that I have to do the whole thing. Alright, so there you go. It's there here using customize. Why? Right. So I'm gonna deploy this port info out. It's not my application, but just a sample to see how it works. Of course, I need to do the permissions. Perfect. So now we should see a container creating, running status at some point. To the service. I'm not sure if this comes with the service. I guess it does. Let me just double check. It comes with the service. Yeah, it does come with the service. Yes. All right. So it's running. Perfect. There you go. So I'm gonna then why is not showing this way? There we go. Um, and service. Cool. All right, so we got the port info service right there. So the last thing that we need to do is then deploy an actual. We just need to get in with to do that. Right, so let's just find this and see how that looks. RQ2, let's just go this file. Now, and I think I have it right here. So it's called, I have to change. Right, so they didn't have the version on the. I should have just installed it with home. To use it. Anyways, you have the version. Just copy it in this example on IO and then just modify it. Right here. We're gonna copy this. Finish copy and paste. We're gonna copy port info. Fine. Is in the next. You know that, and I believe port info says that we need to have the path is the port info just root, and then That one is fine. And service port is the values are in this. There you go. Implementation specific and port is service individual and service. No, so we go back to service and it's 98, 98, but 98, 98, but it should work. It should work. If not, we need to fix it, right? So let's now deploy this ingress and see how we can apply value of let me go back to PL. We are in the place. Cool. So we now can say that we have the QCTO, the ING. Cool. So it's doing the entire host, so it's not tied to a domain. So when we go to, let's just get one of these IPs. So if everything went well, we should be able to just get the 40% point. All the host addresses, ports. Did I miss anything? Did I target service? Unless I'm pointing to the wrong service. Oh, I know why. I know why. The issue is with the Nginx. So here's what's going on. The Nginx did not didn't got the actual IP to work. So we just need to make them do it. And I think I know how because I have it right here on one of my playbooks template. Should be fine. Yeah, that should be fine. Unless I'm missing something else. I think I'm missing something else. So what I can do here is think I have to point it to the domain. So that's why. Okay. All right. So let's try to do one thing before we fix that. So the other thing that I wanted to show you is, so what if I need to upgrade the version, right? Which is probably the most important one, right? So what I was showing you before is there's two ways that you can upgrade. You can use the RKE controller system upgrader. What it does is just creates a CRD on the system, and then it just updates itself when he finds and matches. So although it's cool, I want to show you the manual upgrade because this is kind of like it sounds like magic. So I want to show you the actual manual upgrade, and then you can of course do the this type of upgrade later. But you basically create these two CRDs. you point to the channel that you always want to be upgradable, and what it does is just watch it. So if a new version comes in, for example, a patch on the stable channel, it will just ping a job and start upgrading the actual Kubernetes itself. But for now, what I'm going to show you is how to do it manually. Right? How you do it manually is with the same script that you have on the Ansible, which is this. Good. And here is the version. So we're just going to change that. We're going to change the version to use a new version. How you get a new version? You just go to this website. Uh, this one. Right here, we're going to the GitHub. Let's say that we're going to the branch. There you go. So this is the new US version. We're going to copy that, and we're going to do it here. So to do this test, I might need to drop a little bit the font because I want to show you two things. Make this smaller. All right. And now I'm going to split the, I'm going to take this out. I'm going to split the screen, right? And you're going to see in the right hand side, I'm going to open, I'm going to start watching all the nodes, right? In the keep conflict, and I'm going to point to the second server, right? And then you're going to get money. There you go, and you're going to of course watch it. So here we're watching the actually to make it even cooler, I'm gonna maybe do something like this. This is rep 127. Oh, no, 129. So it's an actual 129 on the container. So 129.1. It's gonna be. Oh, wait a second. What is in version 129 already? The auto grade already? Oh. Oh. Don't tell me that I updated it. No, I shouldn't. Everything looks okay. So the workers are in 129, but the control plane are not. Interesting. Okay. All right. So I'd buy that. For some reason, the worker got the plane 129. Okay, that's cool. All right. So we're gonna see the control plane upgrade, and we'll figure out what I did wrong later. So now we're gonna uh, run the Ansible again, but this time you will see that the control plane. Let me just take this off real quick and show you what I mean. So the control planes that you see here. There you go. The control planes are in 126, and then the workers are in 129. So the control plane is going to basically upgrade itself. Do that. Now run this. There you go. Okay, I think I know what's going on. For some reason, there's a whole. There you go. It detected some changes. Okay, it's gonna take a second. There you go. So you see, it's already okay. So it shut down that server. But if I do the second one, this one, it still works. There you go. So that means that the API is still going to be working. It's just that that one server is not responding, and now it's going to take the second server once the first one is ready. Do it like a rolling upgrade on those servers. It- do we have any questions so far? ¿Alguna pregunta por ahora? While we waiting for the upgrade. It's almost done. So some of them are already in a ready state. So we're good. There you go. Now it's doing this server, so we can go back to the previous config that is pointing to the first server. There you go. And it should be good now. Should be finishing any time. No, ready state. Now, so it's upgrading these workers, but it's going to be pretty quick because they're already on 1.9 for some reason. I don't know why. Maybe there's a table that I omitted and just took the last one, the last version. Okay. And now the last part of the demo that I'm going to do is let's add a new node. What happens if I got a new server in the rack and I want to now bring it to life? So I'm gonna provision it using Equinix, and then we're gonna run this script again to actually bring it to the code. Right. So we're gonna do that in a second as soon as this script is done. This is the perfect time for questions. This is usually the part where when we're dealing with infrastructure, we just need to wait. We don't have any other options. Right. It's done. There we go. All right, while we're waiting for that, I'm gonna show you how to do the Equinix thing. So the Equinix part, we're gonna do the following. We're gonna come here to our uh, Terraform, and on the main, we're going to be doing the following. You see, we have this control plane with 3 nodes, right? And then we have a pool called Heat, and they are in Silicon Valley and 3 nodes. So let's add right now 2 more nodes. So let's do it. And what this is gonna be doing is basically bring another 2 nodes to life. Okay, it's almost done. So interesting enough, so just to explain what's going on here is that every time it's doing the cordon, drain, uncordon, ready state. So that's why it took a little bit long because it's basically looking at all the pods and basically sorry all the nodes and do it one by one. and actually that's how you want it. You want it to be progressively. You know, just you cannot just like get the whole thing down. You want to do it way into everything is done, so far, so far. So it's kind of like expected behavior. So we now get the nodes, all in raised state, cool, all fine. We also get the all the pods that are in running state. Some of them terminating, of course, because we don't we don't need them anymore. But basically, everything is looking good uh, from that standpoint, including our pod info, which is also important. Right. So now, what we need to do is how we can now bring these new two nodes, provision it, and then get the Ansible part. Now, one of the reasons why I chose to do it also separate in two steps is because that's what usually is going to happen. So in the bare metal environment, you just know, it's just not like, oh, here's the server, get it. So usually you get the server first, this provision, and then you act on it. So in this case, I'm simulating that. So let's do the tofu A, do it in the right direction, right? So it's gonna now tell me, hey, you got two more nodes that you're gonna bring into the fold. Great. It's gonna destroy one. Oh no, it's not destroy. It's gonna update the actual data plane. So it's gonna be two more nodes in the data plane. That's what it's done. Great, cool. I'm happy with that. Let's do it. So I'm gonna get these two nodes in. But what that means, and now let me show you how this looks like here. We are getting two more machines. Within this middle, right? So it's provision them. Um, so let's just do this. Go. Same thing with well, this is deploying, which is actually pretty fast. Deploying a bare metal as a service and everything is amazingly fast. So just to give you an idea what I'm trying to do next, and second part is, so even though that is nice that we have this high available conflict plane and all these workers and we can bring them into the fold, I want to have two things. First, I don't want to deal with the fact that I need to figure out the ingress part. And it's a bit tedious, of course, even though that there's something there that we need to fix. Um, but I also want to be able to just use one IP for the content plane instead of having to deal with three IPs. And therefore, the answer to that is using two things. Either you can use keep alive, right? And keep alive will help you have that floating IP between servers, right? And it kind of does that trick. Um, in environments where you're using, for example, you are in layer two, that actually will work perfectly because then in layer two you have these range of IPs, right? And then you pick one as your floating IP. And this software keep alive, it was just basically going to um, assign that IP to a server, it's a primary or initial one. And then if that server stops working, it's going to swap that IP to the next server into and so on and so forth. So that's what keep alive will do, right? The same thing I think does pacemaker. So you have that option. Um, you also have another one called Qpip, which is basically the same, but it's a more cloud native software that allows you to do the same thing. So you just rotate that IP using BGP. At the end, is using BGP, Qpip, so we will have to configure BGP to make it work. That's why I'm going to do it in the second part because configuring BGP does require some um, it had to be slowed down, and we might need to just right into the demo, jump into the demo at the beginning of the session, right? So, which in this one we didn't have that time. But now the servers are up, right? So now we're going to take a look. The control servers are there. Awesome. And now if we do the kubectl game node, of course, we shouldn't be able to see them, right? So there's nothing there. So we have the VP0. These WK things don't really worry too much about them. It's because I made the mistake of because I was doing some tests and I was using WK, and then I forgot to that I changed it to DP. It's a WK, so it's there. So all we have to do is remove those nodes from the control plane, but it doesn't really matter. They won't affect us. It's just the control plane says, "Hey, I got three nodes here that are not ready. I don't even know who they are, but we don't need to worry about them. It's just in an issue in the control plane. For the next one, we will clean it up. So now the real thing here is okay. So now that we have those two nodes, right? These are the ones that we worry about. We only have to let's bring the other two into the fold. So now let's do the uh, side by side again, and we now going to do kubectl and node grab EP and let's do watch. Watch. There we go. And oh, only if I do this config equals to 10, and we do equals, and then let's do it again. Perfect. So we have only two workers, two data points. Uh, so now let's bring them to the fold. So we're gonna do Ansible. Oh, before we do that, let's show you how it looks like the host file inventory. So you see now we have these four. So there's two more that we need to bring into the cluster. So those are the two that I want you're going to do. And you can see it updated itself automatically. So let's do the answer now. If I can spell. Okay. And oh, okay. I need to get into the right folder again. Now we. All right. So last demo. I do apologize. I took a little longer than expected. So this is the last demo. So let's just now what is going to happen is without downtime, because I'm using the API, we should be able to add two more nodes to the cluster. Right. So just if you can see here, it's only working on the new servers. Nothing else is touching, right? Which is good. That's what we want. We don't want to repeat ourselves all the time. So Ansible is doing a good job in that one. Now it's installing the packages. That's why it's taking long, because it's going to all those two new servers and say, hey, you need these packages in order to work. And it's using the apt-get and all that, which I can briefly show you why it's doing that. It's basically getting into this playbook, the install, print, right, is running this one and it's doing the role, he's getting the tasks, he's getting I believe this one, this one, there you go. It's running through this playbook, which is basically going through all that. And the server, it's this one. There you go. So it's doing this. And you see, it's in the step of installing packages. So that's what it's doing. This is it's going through these scripts. Um, you can take a look at the. Oh, okay. Look at this. I want to show you. This is the kind of configuration I was saying about keep alive. So you can see it's configuring keep alive, and that's the one that it uses for basically the higher level. So that's pretty cool. Right. So let's just give it a second. Oh, there you go. It show up the first one. Okay, oh no, yeah, no, no. That's just the watching part. All right. So it's running the hierarchy. It's good. Almost there. Almost there. Any question? Oh, I see a question here. Or potential question. Oh no, that's a clap. Thank you. I take the claps too. All right. So not yet. All right. Now it's getting into the actual thing. Configuring the configuration. All right. Now it's getting in the fun part. So it's starting the service. That's what we want. So now that it's starting the server, there you go. There you go. Nice. That's what I like. There you go. So now it's just starting the hierarchy to service, joining the cluster. At some point, we'll change to ready, and we should be good to go. There you go. So they are in ready state now. The funny part, which I don't know if you notice, is that some of them are on the 126, which is interesting. Probably what's going on is that the configuration here, the, this one is not being. It's still 126. Oh, I know why. I know why. Here's the mistake that I made, which um, I'm glad that happens to me, so it doesn't happen to you in the future. And this is not. This is an issue based on the fact that I forgot that I shouldn't be changing this here because this is a dynamic file. Every time that I run tofu, it will change it. So the real place that I should be changing that is in the output here, uh, and that is so right here in the page. Um, where is it? Output. So here it's calling this main this variable. Okay, so there you go. So this is it requires an RQE2 version variable, which I'm not passing. That was my bad. I should be passing here a variable called RQE2 version, and I should be doing something like this, like RQE2 version as well. I know a lot of repetitions, so I apologize. And then we should pick a variable here called RQE2 version, times string, and then we should be able to just get the TF bars, whatever. This is local, so it's okay. I'm not making anything crazy here. Which is why when I was running the previous version, one got installed with the 126 and the other one with the 129 because every time that I ran the trophy, basically was rewriting my own file, and then when I was running answer telling me like, all right, so you want me to install a new version. All right, I'll install it. The one thing that this answer was very smart to do is that if it's already in a really latest version, it won't downgrade, right? Which is pretty cool. So it's not downgrading. It's basically focusing only on the. Actually, it is downgrading. Oh yeah, it is downgrading because I ran it with the 1.6. Yeah, so it should be basically now changing to 126. There you go. But anyways, at the end, the point of the demo was to show you first that you can install Kubernetes in a bare-metal exactly as you do in another environment, right? So if you have to install it in virtual machines, it will be exactly the same. Where is the difference? Really, is in the networking. Usually, when you're installing Kubernetes in a cloud environment, you install the cloud controller. That's why you have access to this load balance thing. When you are in a bare metal environment, you don't have that luxury, or it's not magically built in. So you have to use what's around. Like I say, usually you can just do it like I did. You just install the ingress, and the ingress automatically um, match just attached to the port 80. I believe I should be, instead of pointing to this one, I should be pointing to one of the nodes, I guess. That's why it didn't work, I believe. Let's just test if that's right or not. There you go. It did work. So it was my bad. I was trying to reach the control plane IP instead of the worker IP. So basically, just to recap, is that installing this way in the bare metal part, you have to configure the ingress, sorry, the ingress controller, or whatever other controller you're using, to basically tie itself to the actual ports of the nodes. In this case, the reason why I use RKE2 is because they made it really easy to do. You can do it with Qdot, with QBDM. You could do it with anything you want. You just have to make sure that you do that trick, right? If and only if you want to simulate a real bare metal environment. Now, what happens if you say, Angel, can I use something else? Do you have to do it only that way? No. You could instead, let's say, use a load balancer. A load balancer that is pointing to the actual workers IPs privately. So the only customer facing IP that you have is the load balancer, which actually would be a preferred way. Having a load balancer firewall doing that trick. But once again, the reason why I didn't do in this part is because I wanted to be like, what if I don't use anything? Just plain, plain servers, whatever they give me. In future episodes, what I would like to do is hardening this a little bit more. Instead of using, let's say, public IPs on every server, what if we use it all private? What if we put on top a load balancer? What if we put, how can we manage networking in a better way and use another open source tool called Netflix? So start putting things together that you can build around it, and you will see that you can become, basically, you can create your own cloud like environment in your, let's say, data center or in your demo. That's kind of the idea that I'm trying to do with these um, few episodes that I'm planning to do. So I think I'm gonna stop here. I took 33 minutes more of your time. I don't know if there's any questions, comments, anything that I can, questions, comments.
Just a quick comment. I was going to say the automation was impressive, like, very impressive. The infrastructure skill was impressive. The learning was impressive about like the performance gains from being on bare metal hardware and the points that you made about the environment control. But most impressive of all was the consistency in the debugging, right? Like that's like a very underplayed thing in this industry. And it's like, you have to have the persistence. And in the end, like it totally worked out. That was extremely impressive. So that's my little comment there.
I appreciate that. I appreciate that. Yeah. So this is like the fun part about when you're doing demos. Like, it doesn't matter if you test it 20 times, something will happen. But yeah, I appreciate that. And then the one of the things that I'm gonna show later is that benchmark, like this pod that you see running here, that you also can run anywhere. The difference is like 10 times more with the same request, the same limits. The actual performance is impressive, and the reason why is because it's not using virtual CPUs, it's using the actual CPU.
I love that. That's so interesting. Yeah, and I didn't know that before. That's something I just learned. It's awesome.
So yeah, I don't know if, if there's any other question. If not, we can just. Oh yes, yes, yes. I'm going to share that code. I'm just gonna basically just remove the private key, of course, and I'll push it to the repository. It's gonna be actually, like I said, it's gonna be a series. So I'm gonna basically I think I name it, if I'm not mistaken, it's gonna be named Open Tofu Equinix RTP, right? So I'm gonna just upload it, and please, I also want to make this interactive. So if you have a better way to do something, please suggest it, because the idea here is to demystify really that, oh, bare metal is hard, or it is not possible to do it, or all these blockers that we put ourselves first, and really it's not that hard. It's actually can be. Oh, listo, así que esté por acá. Yeah. Well, Casey, I think that's it. Like I said, the only last comment that I will have before I wrap up is what I might see here impacting the most is on AI, and the reason is because of the GPU. So if it's already making the CPU 10 times faster when you do it directly with the terminal, imagine how much performance and optimization you can get out of the GPU working directly with the GPU. So that's my final thought. So just that's kind of the awareness that I'm trying to bring. This is not for everything. I wouldn't say, oh, use bare metal all the time. No, but if you have something that really is performance impacting and you really want to get the best out of the actual hardware, then and only then I see this as actually good, good place to start.
And Angel, while we have you, do you want to pitch your talk in Guadalajara that you're going to be talking about on the 24th, so we know what to expect from you?
Yes, and I also want you to mention yours. So
Okay.
yes, I'm gonna be with Casey in Mexico in the 23rd of February and 24th. Actually, the talk that I'm gonna be doing is the continuation of this one, but I'm gonna be adding more complexities, and the reason why I'm adding more complexity is because I want to try to bring this concept like, why are we in Kubernetes still thinking about multiple environments in terms of hardware? Do we really need to basically separate all that? So Kubernetes is already bringing all these like namespaces, isolation. You have this pod security I mentioned. You have the mission controller that you do with Pepper, which actually unlocks a lot of stuff. And you still also have these like new great features from Cilion that you can isolate communication. So why are we still thinking about environments in the hardware level and not at the Kubernetes level? So that's kind of like the multi-tenancy super cluster a concept that I want to bring, and it's gonna be controversial. I know that a lot of people may don't like that. Like today, maybe everyone's like, "You talking about against the cloud?" No, I love the cloud. I love public cloud. It's just that we need to know where the concept really lies and how you can actually get the best out of every tool, right? So, and what is yours? Tell me.
So, one thing on yours, I think today is a perfect time to talk about it because from a very vendor neutral standpoint, I see a lot of people that are actually moving back out of the cloud. Like there is somewhat of an exodus as there was everyone going to the cloud at some point because I mean there's fees, there's a lot of reasons to go out of the cloud, but also the cloud is awesome, right? It's easier. But anyway, so I'm really looking forward to that talk on Hill. And I'm going to be talking about the admission controllers. I'm going to be talking about how to create Kubernetes operators. And this is all with Pepper. It's my company's product, and the product I'm the lead software engineer on. And so we're going to be talking about it in a very high level and what you can do with it. So yeah, that's going to be on 23rd and 24th in Guadalajara, Mexico, and really looking forward to it. Hope you all can make it.
Absolutely. And by the way, you know that just as a, it's not a spoiler, but please, everyone that doesn't know anything about Pepper yet should go and watch and see the talk, because I actually start doing my own
Cool.
stuff with Pepper, and it is so much easy than doing it in Go with Cube Builder and all the stuff. So definitely, for those that might be on the fence of building things in a mission controller, because Go and Cube Builder is not that easy. Pepper, definitely.
Thank you. Yeah, definitely reach out. Pepper now has a Kubernetes Slack channel. But anyway, hey, it's been a pleasure. Angel, thank you so much. We learned a ton. So yeah, thank you.
Thank you.